All right, let's see if this works. Shoot. All right, here we go. Now it's all good. All right, last week we talked about two-step equations with multiplication and addition or subtraction. If you look at this equation, if you find the x term, you notice that if you box the x term, this time the box, inside the box, has division. So if you know how to get rid of division or what operation undoes division, you'll be able to solve for x as well. So in this case, if we're going to try to get the box by itself, we're first going to have to get rid of the positive 1. So we're going to subtract 1 on both sides. We bring our equal sign down here. If you get rid of the positive 1, the only thing left on the left-hand side is going to be x over 13. And if you put 4 and negative 1 together, hopefully you're thinking 3. From here, looks a little bit different than last week. Instead of having multiplication, x is being divided by 13. So the inverse of dividing by 13 is we're going to multiply by 13. Now, if you look at this, these 13s on top of each other. 13 divided by 13 is equal to 1x, and that's what we want. But if we multiply by 13 to keep it balanced, we're going to multiply by 13 over there as well. And we have x is equal to, and 3 times 13 is 39. Now, to make sure that our answer is correct, there's something called a check that you should do. So we're going to plug in 39, and we're going to divide it by 13. We're going to plug it into this equation right here. So we're going to add 1 should equal 4. Well, in GEMS, would you divide first or would you add first? Hopefully you divide. So 39 divided by 13 is 3. And bring your plus 1 down, and 3 plus 1 is 4. 4 is equal to 4, and it checks out. Let's move on to the second one. 2 plus x divided by negative 4 is equal to negative 6. Again, box your variable term. And again, I sure hope you see inside the box division. So to get the box by itself, or the term with the variable in it by itself first, we have to get rid of whatever's attached to it. So we have a positive 2 attached to it. And to get rid of a positive 2, hopefully all of you are thinking, let's subtract 2 or put a negative 2 on both sides. This creates a 0 pair. So on the left-hand side, all we have left is the box. So we're going to bring whatever inside the box and rewrite it. And on the right-hand side, you put a negative 6 with a negative 2. Hopefully, you get negative 8. Now from here again, just like last problem, instead of multiplication, we have x divided by negative 4. So the inverse of division is multiplication. But to undo negative 4, we multiply by negative 4. And now we have a negative 4 on top of a negative 4, which is 1, because a number divided by itself is 1. But this time we're going to multiply by negative 4 on the other side. This is 1. 1x is equal to x. And a negative times a negative is a, hopefully you're thinking of a positive. And 8 times 4 is 32. And again, you can also plug that in. My students have to check. I know Mr. Boland it's not mandatory for you guys to check, but I'm showing you that if you wanted to check, you could. And you could get 100% on every single assignment that has equations. And again, you have addition and division. So obviously in GEMS we divide first, so it's 32 divided by negative 4. Hopefully you're thinking negative 8. You're going to bring your positive 2 down. And if you notice, the left-hand side of this equation when we check is basically a funnel method, or the GEMS. So 2 and a negative 8 is negative 6 is equal to negative 6, and that checks out. All right, let's do the next one. Again, let's box. I want you to work on this one by yourself, which you box the variable term, and I'm going to give you a second to do that, and then I'll work through it, and hopefully your work checks with mine. Go ahead, begin. At this time, you guys should be solving this equation, not looking at your neighbor or sitting there doing nothing. I was going to work through this process, I would box the variable term. I would get rid of the positive 1 so I could get the variable term by itself first in order to get x by itself. So then I have x divided by negative 17 is equal to a negative 2 and a negative 1 make a negative 3. And at this time, I'm going to have to get rid of division by using multiplication. So I'm going to multiply by negative 17. And again, you guys should see that negative 17 over negative 17 is that 1x that we want, that magic number 1. And we also have to multiply by negative 17 on the other side. So if you look at this, on the left-hand side, we have x by itself, which is what our whole goal of every equation is to solve for x. And a negative times a negative is a, hopefully you're thinking positive there. You don't have to put that sign, but just holding the spot for the sign of the answer. 3 times 17 is going to be a 51. Again, you can check this by just plugging 51 in for where x is in the original equation, writing it left to right, making sure that everything looks good. I'm going to divide first, so I got negative 3 plus, whoa, 1 second, plus 1 is equal to negative 2, and then a negative 3 and a positive 1 is also negative 2. So that positive 51 keeps the left side and the right side equal. Hopefully, if there's any questions at this time, I want you to do one more, and then I'll let you work on some homework. I'll give you the assignment that Mr. Bowen and I compromised. So, find the x term. Notice this time it's on the right-hand side. Necessarily, it doesn't have to always be on the left-hand side. So again, we're going to box the variable term. And this time, hopefully, you know what term to get rid of, so we can get the box by itself. I hope everyone's thinking. Getting rid of the negative 7 with a positive 7. So when we create that zero pair, so remember, in two-step equations, the first thing that you do is you create the zero pair. Okay? The second thing you do is you use multiplication or division, depending on what's left in the box, okay, to solve for x. So in this case, we're going to first create that zero pair, which is right there, so that cancels. And I just moved my, 1 second, guys. There we go. There we go. So we got, what do we got left? We have x over 4 is equal to a negative 26 and positive 7, same or different signs. Hopefully you're thinking different. Which one of the two numbers had the largest absolute value? Hopefully you're thinking the 26, which has a negative, so our answer is going to be negative. And the difference of 26, which is the absolute value of negative 26, and the absolute value of 7 is 7. The difference between them, hopefully you're thinking 19. Now from here, again, we're going to get rid of that division by 4 by multiplying by 4. And again, if you notice, we have a 4 over 4, which is a 1. And then we're going to multiply by 4 over here as well. And since we have one negative, 4 times 19 is going to be a positive or negative answer. Hopefully negative is what you think. And then 19 times 4 is going to give us 6, 3, 76. Is going to be equal to our x. Again, to check this, I'm going to plug in negative 76 where the x is in, remember the original problem, writing it left to right. So negative 26 has to equal, if negative 76, and we have to divide or subtract, hopefully you're thinking divide. So negative 76 divided by 4 should be negative 19. And then if you put 19 and 7, same or different signs, hopefully you're thinking same signs. And when you have same signs, you're thinking addition. So we're going to add 19 and 7. But because 19 and 7 are both negative, the answer is going to be negative. So that checks out. Hopefully up to this point you guys have done these successfully. What I want you to do, Mr. Bowen and I would like you to try the next problems. We've gone through, on the worksheet, we've gone through 1 through 4. So, actually 1 through 5. And so I would like you to try, finish the problems 7 through 15 for homework on the worksheet. So the problem 7 through 15 for the remaining problems on the worksheet is your homework for tomorrow, due tomorrow. Thanks, guys. Have a great day.